Hi everyone, I am Sneha, co-founder and CEO DevCompass, and I am absolutely thrilled to have you guys here, and I hope that you are thrilled too. We are in video number 4 of stage 2 of the course, and I hope that everything we have discussed before this, you're following it really well, you're having fun, and you're looking forward to the rest of the course as well. For everyone who doesn't know what I am talking about, please head over to devcompass.ai to get some information about the course. In the last video, we talked about how you can't prompt your way to guaranteed compliance. And in this video, we're going to talk about how can you do it. So we discussed that code enforcement is what you need. In this video, we'll talk about how you implement that enforcement without really scattering a lot of if statements across your entire code base. Let's get started. So hooks are the answer. A hook is a function that Claude's SDK calls automatically at a specific point in the agent loop before a tool runs or after it returns a result. You register it once, it runs every time for every tool call without you having to remember to add the check manually in each place. Very clean, consistent, and composable. Now, there are two hook types and they sit at two very specific points in the agent tool. So look at the diagram on the screen. This is the same agentic loop you built your mental model around in stage 1. And that is the section that I've kept blank, that you have to recall the entire flow of that agentic system. And we look at the rest. So, stage 1, Claude generates a response. This loop checks stop reason. Again, please go back to that diagram to get an idea, the diamond shaped. A tool call goes out, the result comes back, and the loop continues. You already know this. Now look at where the two hooks attach. The first hook is a PreToolUse, which attaches right before run the tool. Okay. See that ambered box flying in on left? That's yours. That's your code, and I've already mentioned in the previous video as well that this is our visual representation to tell you that this is not about Claude. If you see amber border anywhere, that's your code. The moment Claude outputs a tool use call and your loop receives it, before you actually execute the tool, the PreToolUse hook fires. It can inspect the tool name and the arguments that Claude has passed. Based on what it finds, it can block the call entirely, modify the arguments before they reach the tool, or pass the call through unchanged. The second hook is a PostToolUse, which attaches after the tool returns, before the result goes back to Claude. The amber bordered box on the right side of the loop is your tool ran, it returned a result. Before that result enters the conversation history and Claude sees it, the PostToolUse hook fires. It can inspect the result, transform it, flag it, or replace it entirely. Two interception points, before execution and after execution. Everything that flows into your tools and out of your tools passes through these two checkpoints if you register hooks for them. So let's discuss about these in detail. So let's walk through a PreToolUse hook example. Look at the flow diagram on the left side of the screen and the code on the right. So the flow diagram looks like Claude outputs a tool use call for process refund. That call arrives at your code. The PreToolUse hook fires immediately. The gate box, again with the amber border, which is your code, checks one thing. Does the current session have a verified customer ID? This is the session state that your code maintains. Every time getCustomer runs successfully and returns a verified customer, your code stores that ID. The hook checks whether that happened or whether it did not. If it didn't happen, no verified customer in a session state, the hook returns the block, which is the SDK's method for stopping the tool call. It passes back a structured error, the same format that we covered in video 2, where there is a category, So it will say prerequisite not met, retriable false, and message telling Claude to run get customer first. So process refund never really executes. Claude receives the error and adjusts. If the session does have a verified customer ID, the hook will return allow and the tool call proceeds normally. Now look at the code on the right. The function takes 3 arguments, the tool name, the tool input, and the arguments. And we've talked about this before. Claude passed and the session object. First, it checks the tool name. This hook only activates for process refund, not for the get customer, not for lookup order, not for any other tool. And that is a very important detail. You can write hooks that apply to all tools or hooks that target very specific ones. Then it checks session state. If the condition isn't met, block with the structured error, otherwise return allow. This replaces the very ad hoc check we built manually in video 3. Same logic, but now it's registered once and runs automatically every time process refund is called, no matter where in your code that call originates from. Now let's look at the PostToolUse hook. Okay, so a different type of problem. The tool ran successfully, but the result needs to be cleaned up before Claude sees it, right? So if you look at the left panel on the screen, your customer database returns dates in 3 formats depending on the region of the customer record that is stored in. One record comes as April 3rd to 2024, another as 20240403, another in a different format. All 3 mean the same date, but Claude receives them as 3 different strings across a conversation. Now, Claude has to reason about whether these are the same date, whether one order came before another, whether a return window has expired. That's work Claude is doing that has nothing to do with helping the customer. It's just normalizing inconsistent data, and it can lead to error if Claude misreads the format. The large arrow in the center of the slide, which is the PostToolUse hook, it runs. Your code intercepts the result before it enters the conversation history. Now, if you look at the right panel, when Claude actually receives is 20240403 every time, one format consistent throughout. Claude doesn't have to think about date passing at all. It just uses the date. The inconsistency was resolved in your code before Claude even saw it. So the caption at the bottom is kind of an emphasis on that Claude never saw the inconsistency. It was resolved before the result entered the context. That's what PostToolUse hooks are for. They're not just blocking, but transforming, cleaning, normalizing, filtering, making the data that reaches Claude as clean and consistent as possible. Now, okay, now let's look at how this is actually working. Like we've seen a very interesting state already. The second example here is way more interesting. This one doesn't normalize data. It intercepts the result and replaces it entirely based on a business rule. So looking at the flow chart, we go at the tool process refund. It runs. The amount is $650, let's say. The result comes back from the tool. Now the PostToolUse hook will fire. Again, the ambered border gate box, it's your code. So it will check, is the amount greater than $500? It is. So instead of passing the result through Claude, the hook replaces the result with something clear, completely different. Look at what Claude actually receives in the right side of the flow. It is not the refund confirmation, not a success message. It's an escalation instruction. A structured object with action, escalate, a reason explaining that $650 amount exceeds the $500 limit, and an instruction telling Claude exactly what to say. Inform the customer that this requires human approval and offer to connect them with a specialist. Now, Claude reads this as if it were the tool result. It has no way of knowing that the result was replaced. It acts on what the hook actually returned, which is the escalation instruction. In the end, you see that the tool ran. Okay, the result can be completely different from what was the actual scenario and what was logged and audited. The state change can be logged, audited, or tracked, but Claude's view of the result was intercepted before it could communicate approval to the user. And Claude cannot override this. It only sees that the hook will pass through, and this is something that we have to keep in mind. Now, before we finish, I want to give you a very clear reference for what hooks can and cannot do, because exam questions will try to trip you up here by describing hooks doing things they're not capable of. Now, look at the left column, what hooks can do. They can block a tool call before it executes, the PreToolUse pattern. They can modify tool inputs before execution, that is changing arguments before the tool even receives them. They can transform tool results before Claude sees them, the normalization pattern. They can log every tool call and result, which gives you a complete audit trail of everything that moved through your agent. They have access to the session state. They know what was already run in this conversation. And they can redirect Claude by returning a very different result content, like the escalation intercept pattern. In the right column, what hooks cannot do. They cannot alter Claude's previous message or memory. Whatever is already in the conversation history when the hook fires stays exactly as it is. They cannot run outside the tool call events. There's no hook for Claude is about to generate a response or a user message just arrived. Hooks fires at tool boundaries, not anywhere else. They cannot override Claude's reasoning mid-thought. Hooks operates on inputs and outputs, not on Claude's internal processing, and thus they cannot add tools dynamically during a session. The tool list is established at the start. If an exam question describes a hook doing anything in that right column, it's a distractor. Hooks are powerful within their scope. That scope is tool call boundaries before and after and nothing else. And for that you have to remember the diagram that I showed a few slides ago. So that's it. In this video we talked about PreToolUse, which runs before execution, PostToolUse, which runs after result, and most importantly that you have to register hooks once and it will run every time. There is no scattered ad hoc checks. So the walkthrough in the course after this video gives you 2 hooks to implement. First, a PostToolUse normalization hook that standardizes date formats from inconsistent database results. Second, a PostToolUse escalation intercept that replaces refund results above $500 with an escalation instruction. And you have to build both. When you come back for the final video in stage 2, it is going to be all about MCPs, how you take all of these tools that we have been building and expose them in a very standardized, scalable way that multiple agents and multiple teams can share. So I will see you in the next one.